Hello, everybody. Good to see you back. Here we are starting our new week, and I'm about to record our next set of lessons. So we are on page 73, starting with number 15, where we left off with our lesson. So we will have a full week this week, and I look forward to seeing all of you present. Here we are. I'm going to share my screen so we can get started. All right, so here we go. Bringing back our lessons. Here we are on page number 70. I guess it'd be 67 on there, but in your notes, it should be 67 of 79. And we have actually 90 pages in our lesson. So it should be somewhere around page 73. But again, we're in unit 4, problem number 15, okay? So just follow your page numbers just in case I'm looking at some different pages. All right, here we are. We're continuing with our probability, and we're looking at now problems concerning our deck of cards. So remember that on the test, I'm going to give you this picture or set of cards. I'm going to talk about them really quickly. So you don't have to worry about memorizing the deck of cards if you're not familiar with them. So don't worry about that. Okay. So our problem says, suppose we are drawing a single card from a standard deck of cards. And they want us to find the probabilities that in these situations. So we're talking about this standard deck of cards. So let's take a look at it. So here we have a standard 52 card deck. This does not have jokers in it. So if you are familiar with the deck of cards, you have 2 jokers in there. So that does not include those. But the standard deck has 4 suits. And the suits are clubs, spades, hearts, and diamonds. Right? Again, you'll have that listed out on your sheet. In each suit, there's 13 cards. So you have 10 numbered cards and 3 face cards, okay? Or they call them picture cards. So you could say picture cards or face cards. That's a jack, a queen, and a king for each suit. You'll see that you have 2 suits that are black and 2 suits that are red. So they'll give you problems that ask you about their color. You'll ask about the picture cards. You'll ask about the number of the cards. It'll ask you different variations. So if you don't remember, don't freak out. You'll have this with you on the test. All right. So I do recommend that you look at them and do become familiar with the standard deck and what these mean. Again, know that the suit means that each one of these areas are called suits. Know that these are called picture cards, and these are jack, queens, and kings. And know that each suit has 13 cards. Again, you can count them yourself, but you have 13 cards in each suit, right? Okay, so now that we've kind of gone over that, that's going to help us answer some questions here. Now, we're drawing a single card from this 52 card, from a standard deck of cards. So right here, this tells us that our denominator is always going to be 52. Because that's how many cards are in our deck, which is our sample size. So remember, our sample size is always going to be our denominator based on what we're talking about, okay? So here, The first thing is to find the probability that P, probability of getting a queen. So they're going to have this deck of cards, shuffle them, and then you're going to pick a card, right? What's the probability that it's going to be a queen? So remember, when we come down here, we'll see that we have 4 queens in the whole deck. The whole deck of how many cards? 52. So our probability, which remember is always in fraction form, so the denominator is always the total number of ways that something can happen. That's our 52. And then the numerator is the number of ways that this situation can happen. How many queens do we have? 4. Now in the homework, you could put this in your homework and it should probably give you the correct answer. But I would always like for you to reduce your fractions. But again, if you put it 4 over 52, that should still give you the correct answer in the homework, okay? Give it a try. You know you have 3 times to get it right. So see what it does and see how it feels. Even though sometimes the directions says to reduce it, do it. Sometimes it doesn't say reduce it. You can still reduce it and put it in and it'll give you the correct answer. You can put it in as 4 over 52 and it'll give you the correct answer. Okay, I did it several ways and it worked for me. But we're going to reduce it here. 4 goes into 52. How many times? 4 goes into 4 one time. 4 goes into 52 13 times. So a probability of it happening is 1 over 13. So we see, talking about the standard deck of cards, we're looking at the probability of this thing happening, right? Whatever the situation is, we're putting it over our denominator of 52, and if you can reduce, reduce it. Okay, let's roll with it now. This next one, and then you can pause the video and try the others for yourself. All right, so we have the probability of pulling a heart. Now, how many hearts do we have in the deck? Remember, here's our suit. In each suit, we have 13 cards. So we have 13 out of 52. This can be reduced to 1 over 4. All right, we see what we're doing, hopefully. Pause the video here. Try the next 4, and then push play, and we'll come back and check her out. Okay, here we go. We have the probability of pulling a black card. Now, how many black cards do we have? We have 2 sets that are black cards. So 13 plus 13 gives us 26 cards. So we have a total of 26 cards out of our 52. So when we reduce that, that's half of the deck. So 1/2. All right, hope you got that. All right, looking at the probability of pulling a picture card. So looking down here at our deck, we see that we have 3, 6, 9, 12 picture cards. So we have 12 total out of our total 52 deck card, right? So 12 picture cards out of the 52 card deck. We can simplify that into what? What did you get? Now remember, in your calculator, just to make sure we remember, again, I'm using the graphing calculator. You'll want to put in 12 divided by 52, push enter, and you'll get a funky decimal. So you'll get this in your scientific calculator as well. Then in your graphing calculator here, you'll go to your math button. It's already on fraction. Push enter twice, and it will reduce it to 3 over 13. In your scientific calculator, again, you're looking for the F to D button or S to D button, or you're looking for your toggle button, which is the two arrowheads pointing opposite direction, depending on your model of your calculator. Again, if you have trouble finding these things, please Google your calculator and you can find out. Of course, we can meet in office hours as well, and then show me your calculator and I can find it for you that way too, okay? Then we have E. E says the probability of a red card and a black card. So this word and here, you've seen and before. So and, we're talking about where they share, like it could be both. So we look at our deck of cards. Do we have a card that can be a black card and a red card at the same time? No. So this can't happen. All right? There's no card that can be both a red and a black at the same time. So that would be 0 over 52, which reduces to just 0. Right? Can't happen. So what does it mean? No card that's both red and black. Okay. Then we have the probability of picking a red card or a black card. Now, or means we're going to take in consideration that we can pick a red or a black. So that means combining the two, right? So you can pick a red or black. That would be every card in the deck. Okay. So this covers all cards, right? So all the cards in the deck would be all 52 of them. So you have 52 divided by 52, which equals 1. All right. So thinking about our deck of cards, what they're asking us about the deck of cards, and remembering our words and or. So and means can something be both those things? Or we're talking about one or the other, right? If it's okay, if it could be a red card and a black, and you pick a black card. So you just add all those things together. Okay? All right. Let's move on to the next page. Here we are looking at complementary events. So now when we think about complementary, what are we talking about? We're talking about things that complement each other. So when we're talking about complementary, think about 100%, right? 100% of something. And if I tell you that I want you to give me, let's see, if you have 30% of the candy, who has the other percent? You know, if you have 30% and John has the other part, then how much does John have? Right? He would have, that's right, 70%, right? So complementary events, we're talking about, let's see, talk about rain here. So let's say the probability of rain plus the probability of not rain would equal what? 1, right? So if you have the probability of rain and the probability of not rain, that would equal 1. Right? So for instance, if I said, if I tell you we have, I don't know, let's see. If I tell you we have a 60% chance of rain, all right, then you know that there is a what chance that we don't have rain, right? That's right, 40%. Then %40 chance of no rain, right? So 40% chance of no rain. I'll erase it. I just wanted to use the eraser. Isn't that cute? Okay, sorry. I love this stuff. Okay. All right. So we have a 40% chance of no rain. So if you have percentage of rain equals 0.6, right? And then probability of no rain, late. So probability of not rain would be 0.4. This totals up to be your 100%. Right? So here's what we're talking about. Complementary events. So the probability of one event plus the probability of not the event should equal 1. Therefore, if I wanted to find out, say we were missing this information and I wanted to solve for it, right? What's the probability of something not happening? Then what I'm going to simply do mathematically is I'm going to solve this equation for this probability of not the event happening. What are we going to do? We're going to subtract the probability of the event happening. I'm just simply going to move it over to this side of the equation. So not. Okay, I just simply subtracted it over. It cancels from here. And it leaves me the probability of not the event happening equals 1 minus the probability of the event happening. Okay, we're going to use this right here to help us this next set of homework. So it could be very important. So read the problems carefully when they're asking you for an event not happening. You're going to be looking to use this formula. Okay, let's try it out. Using the idea of complementary events, we're going to find the following probabilities. Here we are talking about that deck of cards again. So drawing a single card from a standard deck. Here we have the probability of not drawing a queen of hearts equals, here's the formula, 1 minus the probability of drawing a queen. All right, so in order to find it, here's our formula laid out for us. We did that one for us so we could see the structure. So always write out your structure first, and then you can fill it in. It always helps to keep you straight. So here we are, we're looking for the probability of not getting a heart. So the probability of not getting a heart, what are we going to do? Take this 1 and subtract it from the probability of us getting a heart. What's the probability of us getting a heart? How many hearts are in the deck of cards? We know from our standard deck that it's 13, right? So we have 13 all over 52. Now, we don't really need a calculator for this, but if you want to use your calculator, you would put this expression here in your calculator and press enter, and then change it into a simplified fraction. But 1 is our friend, so let it be our friend, okay? So we have 1 minus 13 over 52. Let's go ahead and change the 1 into a fraction that's going to help us. And what fraction is going to help us? Change it into, that's right, 52 over 52. So we have 52 all over 52, which is the same as 1, minus 13 over 52. Now we have everything has the same common denominator. And then you can subtract. You can use your fingers for that. I do. If it ain't broke, y'all, don't fix it. Okay? Now what? What are we going to do? Now, ooh, I wish I could give you some points. Right here, I was thinking about giving some bonus points. Can anybody see why I could give you some bonus points? But I can't. Maybe if we came to, I don't know, maybe I could work it out, but not this time. Look and see what I did. The problem asked me for what? It says the probability of not a queen of hearts. Did the problem say not a heart? Didn't do that. It says specifically a queen of hearts. So now, how many queen of hearts do we have? Just 1. Okay? So I did that to say this. When you're looking at the deck of cards, be careful. Even us experienced card people, when you're going fast and you think you know, going fast, you don't pay attention all the time. So if you look, the problem is being very specific here with what heart they want you to look at. When I filled in the problem, I was talking about all the hearts, and they just want to know about the queen of hearts. Is everybody all right with that? Good. Now let's make the correction. This could be very important on the test. I don't know, but I know you'll pay attention if you have a problem on the test about it, right? Okay. So now, here we are with the correction. It says we're solving for the probability of not a queen of heart. So we have 1 minus the probability of a queen of heart. And how many queens we said we had of a heart? Just 1. We're still going to solve it the same. Again, you can put this in your calculator and work it, but we don't really need to do that because we know that 52 minus 1 is just 51. Very simple. Don't need a calculator for that. Some of these problems, you don't really need a calculator. It's just some simplification. And when you're doing them enough, you'll see a pattern start to happen. You'll see some familiar numbers to continue to happen, especially when you're dealing with just the cards. Then you'll see a pattern of those things. When you're dealing with dice, you'll see the pattern. When you're dealing with flipping a coin, you'll see the pattern, okay? So use that to your advantage. It's not very difficult. You're just paying attention to what they're asking you and what your sample size is and what your sample is, okay? Let's try the next. So it says the probability of not a picture card. So this is what we're looking for. Now remember, we've already practiced writing our structure. Here we are writing our structure. So the probability of not a picture card would be 1 minus the probability of a picture card. There's my structure. So now we have 1 minus the probability of getting a picture card. How many picture cards did we say we had again? Do we need to go and look? So again, remember, you'll have this on the test. So we have 3, 6, 9, 12. 12 picture cards. So we have 12. Oh, 15. So we have 12 out of 52. And again, when we do our math, again, you can put this in your calculator, or you have 52 out of 52 minus 12 out of 52. Do the math and you get what? You can pause it here and work it out. Or remember, you have 1 minus 12 divided by 52 equals that funky decimal. Then you look for your second shift in your scientific calculator, where you're changing your decimal into a fraction. Here we're changing it with our math button. We get 10 over 13. All right, how do we feel about it? Shouldn't be too bad. All right, just some simple math of subtracting some whole numbers with fractions, finding our common denominator if you're doing it longhand. That's why I'm showing this part right here, because some of us don't want to do the calculator. That's fine. Use what you know about 1 and change it into a fraction. That helps. And then just do the subtraction in your simplification. You're putting it in the calculator, go here, push enter, and then change it into your simplified fraction. All right. Pause the video here now and try the next 3. Remembering here that we're changing into rolling a single die. And then we can come back and work the others together. All right, see you in a bit. Okay, here we are. Says probability of not an ace. So we have 1 minus the probability of getting an ace. Now, they did not say what kind of ace. So we're just talking about all the aces in the deck. All right, so here we are, 1 minus the probability of an ace. We have 4 aces out of 52. So then we have 52 over 52 minus 4 over 52, which equals 48 over 52. All right, now do the math or use your calculator. Again, you can put 48 over 52 in the calculator. 48 divided by 52. Please make sure you're using your calculator while you're doing your homework so you can be familiar with it. And then you get 12 over 13. Right. This next one, rolling a single die. Now remember, it's just 1 single die. And they didn't specify if it was some special type of die. So we're going to go with our standard die of 6 sides. Okay, so 6-sided. So the probability of not a 5. Probability of not a 5. So if we got 6 sides, we kind of can picture it in our heads, probably. We already know what the answer is. Let's practice writing it out. So we have 1 minus the probability of getting a 5. So here we have, I'm going to skip the middleman, and I'm going to go 6 over 6 minus the probability of getting a 5. How many 5s do we have on that die? Just 1. 1 out of 6. That gives us 5/6. Can't simplify that. That's what we got. And if you think about it, you probably already knew the answer right off the bat. Okay, you knew you were going to be left with 5 sides that did not, was not a 6. That's fine. Okay. Then the probability of not an even number. Remember, we got 6 sides, so not an even number. So what would those be? So you have 1, 3, 5. So we got 3 numbers, right, that are not even. That means we got 3 numbers that are even. There you go. So we have 1 minus the probability of an even number. Okay, so here we have our 6/6. Again, I'm cutting out the middleman because I know I'm going to change that 1 to 6/6. But the probability of us getting an even number would be minus 3/6. So this would be 3/6, which reduces to half of the die. How do we feel about the cards and rolling the die? Using our complementary events formula, being able to solve, right, for an event that's not going to happen. You're going to use this in your homework. Go ahead and make sure you jump on this so you can get that good practice in, and you can go ahead and get those problems worked out really well in this homework. Okay? So, homework, you're going to need this. It'll help. All right? I think we're going to go to the next page, I think. There we problem number 17. Here we go. All right. Suppose we wish to do 2 things, one after the other. In other words, in succession. Sometimes the probability of the second event will be impacted by the first event. This is called dependent. And sometimes it will not. This is called independent. Okay, so now here we're doing 2 things. Okay, we wish to do 2 things. And then one thing, right, we're going to do it. So it's like here we are, we're going to do, say, doing the cards. Shuffle, pull something out of the deck, put it back, then pull again. Okay? Then we're going to see what happens with those events. So now let's watch the wording going on. When they're going to tell you if it's going to be with replacement or without replacement. Those are going to be some key words for us to pay attention to. So let's look at what they're asking. Suppose we draw a card. We're talking about that 52 card deck. Replace it in the deck, then draw a second card. What is the probability that first we draw a heart, and then second card we draw a heart? Okay, so we have this deck, we shuffle, we pick, it's a heart. You put it back in the deck, shuffle again, you pull, it's a heart. We want to know what's the probability of that happening. Here we go. So now, here we are looking at the probability of this first event happening. How many hearts did we have in the deck again? Yeah, 13, right? So the probability of us pulling a heart, okay, would be 13 out of 52. Okay? Now, if I put the card back in the deck, I still now have 52 cards in the deck. I'm going to shuffle and pull again. So I still have the 13 hearts in there out of the 52. So when I pull the second card, okay, we'll multiply, then I still have chance of pulling from 13 of those hearts out of a 52 card deck. You see that? Because I replaced it back in. So now here's the probability of the first event times the probability of the second event. So probability of Q1 and probability of Q2. All right, the first event and the second event. Now we're going to do our multiplication, simplification, whatever you want to call it. And then when we do all that, again, you could do this in your calculator, or you can go old school with it. And you can say, we know that 13 goes into 52 4 times here, 4 times. And when we multiply across, we get 1 over 16. However you want to do it is fine, okay? Whatever your comfort level is at this point, we know that that's what it is. So if you're comfortable doing it by hand, do it. You're comfortable and want to do it in the calculator, do it. It doesn't matter, all right? So our probability of this happening is 1 over 16. Because our second event was not affected by our first event, this is called what? Okay. Independent events, right? Now let's look at the second one. Same as above, but we do not replace it. So now we shuffle this deck. We pull, probability that we got a heart, right? We put the card off to the side. We shuffle the deck and we pull again. Now you see what happens? Okay, so when we pull this first time, we have the 13 hearts in the deck out of the 52 card deck, right? But remember, we didn't put the card back in. So now, do we have 52 cards in the deck now? No, we have 51 cards in the deck. If this is a heart that we pulled, do we have 13 hearts back in there? No, we would only have 12. You see that? Okay, so think about what's happened. So now, when we did this second event, because if we're saying that this first card that we pull is a heart, then the second card that we pull is going to be affected by that first pull, right? So now let's do some simplification. So what do we have? We have some stuff going on here, okay? So remember, here we have our P of Q1, right? Probability of this happening. But now, this right here, probability of what? Now remember, because we pulled that first card and didn't put it back, now this is being affected. So now we have Q2 being affected by Q1, all right? So this line here represents given. So this second pull, all right, is a heart, given the first is a heart, right? So note that. Because this was affected by it, this is called, what did we say? It's affected by the first thing, dependent. All right, so one is dependent on the other. Now, remember, we're holding the first card, right? So pay attention. The denominator decreases by 1. The numerator decreases by 1, all right? So now, oh, we got to do the math. Let's see how it looks in the calculator. Again, remember, you could do it by hand or do it in the calculator. So you have 13 divided by 52, right? times 12 divided by 51. In some of your calculators, you may need to use parentheses to hold your things together. Some of you, your calculators may do it upright. You know the structure of your calculator. So let it work for you, and you have to get that practice in. That's why it's so important for you to practice on your calculator while you're doing your homework, so that when you get to the test, you're not shocked by what's happening with your calculator, okay? So you have 1/17. All right, let's move on. Toss a fair coin twice. So we have this coin. Could be a penny, a nickel, a quarter, but it's fair. Fair means it's balanced, okay? No hidden things going on. You toss it, falls down, it's a head. You toss it again, second time, it's a head. Now, because it's a fair coin, the coin has a side head or side tail. These have to be independent events, right? Because your second event does not depend on what happened with your first event. Do you see that? You still have equal chances to get a head with both tosses. So right here, these are independent events. So probability of us getting a head the first time would be 1/2, right? And then if we toss it again, probability of us getting a head again would be 1/2. So this would be 1/4. Oh. Is everybody okay? All right? So think about what they're giving us. Think about what's happening. Here we are, number 20. Suppose you have a box of items, 3 pieces of quartz, 5 pieces of shell, and 1 diamond. Find the probability of picking the following if you draw 2 items in succession from the box. All right, now watch these problems now, because they're giving us some details in the problems. So we're picking 2 items in succession from the box. What is in the box? Did they tell us how many items total was in the box? No. They told us the different items that were in the box, but they didn't give us a total. So remember, we're doing probability. Totals are important. So if they don't give you a total in the problem, you got to find the total. Okay, so add up everything. How many items are in the box? I'll wait. Okay, so we have 3 plus 5 plus 1, 9 items total, right? Okay, so now that tells us what our denominator is going to be when we start finding our probability. So it says, what's the probability that we'll get 2 quarts with replacement? So we jiggle the bag, we reach in, pull out a quartz, we put it back, jiggle the bag again, reach in, and get a quartz the second time. Okay, that's what we're doing. And sometimes you got to visualize. So here we are, probability of us getting a quartz the first time. How many quartz do we have in the box? The bag, yeah, the box, 3. 3 out of 9. So 3 out of 9. Then we put it back in the box, shake it up, we pull again, we have the probability, again, is the same, 3 out of 9. These are independent, right? Don't have anything to do with the other. Go ahead and do your math. All right, I'm gonna do it by hand. 3 goes into 9 3 times. 3 goes into 9 3 times. So It's going to have 1 on the top. 3 times 3 is 9. My answer, 1 over 9. Does everybody see what we're doing? All right, let's try the next one. So they have 2 quarts without replacement. So now we're still looking for the 2 quarts, but probability of getting the first quarts, 3 out of 9. But remember, we're not going to put it back in the box. We're going to shake the box up. We're going to reach in and hope we get a quartz again. But the probability is now going to be, that's right, 2 out of 8, right? Because we took that 1, we put it off to the side. So now we don't have 9 items in the box. We only have 8 total in the box. And then if this first one was a quartz, then that only left 2 in the box to choose from. Okay, so here we are. 3 goes into 9 3 times. 2 goes into 8 4 times. So then we're left with 1 over 12. All right, so pause your video right here and go ahead and work these next 4 and then come back and then we'll verify. All right. Okay. Here we are, 1 quartz and then 1 shell with replacement. So the probability of getting 1 quartz. So 1 quartz we know is 3 out of 9, right? All right, and then a shell, okay? Go ahead, So now remember, this is with replacement, so we put that 1 piece back. So how many shells do we have? 5. 5 out of, you got it. So now we're doing our math. 3 goes into 9 3 times. And so then we have 5 over what? And there you have it. Now, same situation, except for without replacement. Okay, without replacement. So now the 1 quartz, that should be the same. You have 3 out of 9. Now you see the pattern. The first pull is going to be your real one, right? It's the second one, if it's without replacement, that's the one where you have to really pay attention with that without replacement, what it's going to look like. So now remember, we're not putting that 1 quartz back in the box, but we still have 5 shells there, right? So we only pull a quartz the first time. So it's going to be 5, but now 5 out of 8, because it's only 8 items in the box now. Okay? All right, do your math. All right. And we get 5 out of, well, Again, remember, you can put this in your calculator. Okay, I'm just doing it by hand just because it's here. All right, now look at this. This next one is 2 diamonds. All right, 2 diamonds with replacement. 2 diamonds. Okay, so a diamond the first time, put it back, then a diamond the second time. How many diamonds do we have in the box? Just 1. So if we're with replacement, we should be good, right? So probability of getting a diamond the first time will be 1 out of 9. We put it back in the box, and we draw again, probability of still 1 out of 9. So we have 1, 8, 1. But now watch this now. What happens when they say without replacement? So the probability of us pulling a diamond the first time is still 1 out of 9. But we're not going to put it back in the box. But we only got 1 diamond. So if we don't put it back in the box, can we pull a second diamond? No. So the probability of us pulling a second one will be 0 out of 8. If we wanted to actually put a fraction, 0 out of 8. 0 divided by any number is 0. Okay? So 0 times any number is 0. That's it. Can't happen because you don't have 2 diamonds in the box. Okay? Any questions? Make sure you bring these to office hours. Okay? Oh, here we are. Problem 20. So again, look for your keywords. With replacement, without replacement. Okay? And then making sure we're looking at our complementary events. I will not ask you on a test if something is independent or dependent. I will just expect for you to know how to work those based on what is being asked, and that you are using them, and this is where your replacement and not replacement comes into effect. Okay, and that's how you would use your dependent and independent events. Okay. All right. I will see you the next lesson. All right. I hope this video helps.